Ever pondered over the intricate labyrinth that is multivariate data analysis? The myriad of variables, the interconnections, the sheer complexity of it all can be quite overwhelming. Today we're going to unravel one of the most effective ways of simplifying this complexity: Principal Component Regression, or PCR. Picture this. You're in a room filled to the brim with different objects. Now, if you were asked to describe each object's position, you'd have to specify its distance from every wall, which could be quite exhausting. But what if you could simplify this by just describing the object's position in relation to 2 or 3 main walls? That's essentially what PCR does with multivariate data. Instead of dealing with a multitude of variables, PCR reduces them to a few principal components, hence simplifying the task at hand. So how does PCR work? It's a two-step process. First, we perform Principal Component Analysis, or PCA, where we transform our many correlated variables into a smaller set of uncorrelated variables. These new variables, the principal components, are a linear combination of the original variables and are chosen in such a way that they capture the most variance in the data. After we've transformed our data with PCA, we then move on to the second step, regression. Here we regress our response variable on the principal components obtained from the PCA. This is where PCR gets its name from. It's a regression, but with principal components. Output. But why use PCR? Well, it's quite the handy tool, especially when dealing with multicollinearity. When you have variables that are highly correlated, traditional regression techniques can falter, providing unstable and unreliable results. PCR, on the other hand, sidesteps this issue by transforming these correlated variables into uncorrelated principal components. Remember though, PCR is not without its limitations. One of the main drawbacks is that the principal components can sometimes be hard to interpret, as they are combinations of the original variables. So while PCR simplifies the analysis, it can complicate the interpretation. To wrap it up, Principal Component Regression is a two-step dance, starting with a transformation of the data with principal component analysis, followed by a regression on these new uncorrelated variables. PCR is a powerful tool for dealing with multivariate data, especially when multicollinearity is a concern. However, it does come with the trade-off of potentially complicated interpretation. So the next time you're faced with a complex multivariate data set, perhaps consider giving PCR a whirl. It might just be the tool you need to simplify your analysis while still capturing the most important information in your data.